LeetCode Problem 153, find minimum in rotated sorted array. So this problem gives us an array that could be rotated, something like this. Alright, so in this case the left side is sorted and the right side is sorted, but the right side sorted array is smaller than the left side sorted array. And then our goal is to find the minimum element of this array, right? And this is important, where we have to write an algorithm that runs in log n time. That means we cannot just use the mean element, right? Because the mean element in C++ is actually in on time, right? So we can't fit and just do this, right? So to implement a binary search, we have to use a left pointer and a right pointer, as well as a middle point, right? Okay, so our goal is to find out at which point do the array is in descending order, basically, right? Okay, so I initialize some variables here, and then okay, let's begin. While left is lower than right, this means that both pointers have not met. So here we check, right? We check whether this number is lesser than this number, which in a rotated array it will never happen. But if let's say the array is not rotated at all, and it is something like this, 4, 5, where in this case the left will be smaller than right, This number will be smaller than this number. And when that happens, we just return the minimum of output and nums left. But in this case, since output is the same as nums left, so you just return the first element. But it did not happen, and we are like this, right? So you can get a guess that this if statement will trigger when we are in the right side of the rotated array, right? Okay, now that this did not trigger, let's find out the mid. So mid will equals to left plus right minus left, right, and then divided by 2. So this will be 4 divided by 2, this will be 2, right? Okay, so 2 is 5. Okay, before that we have a output, and then we check whether or not this number in output is lower than this number. In this case it's not, since it's 5, so we don't do anything. And then we check whether the middle point is more than the number on the left or not, right? In this case, if the middle point is more than the number on the left, we know that we are still in the left side of the sorted array, right? That means we have to move our left pointer forward. Actually, we have to move our left forward pointer to the right, basically, right? So that's what we did. Left equals to mid plus 1. Remember mid plus 1, this will be 3. Okay, after that, then we check again, 0, 1, 2, 3, whether or not our left pointer, our left number is smaller than our right number, which in this case it is. So we'll return the minimum of output and a left number, right? So remember, output is 3, and the minimum is 1. It's more like the left pointer is 1, so we'll just return 1. Okay. Let's go with another example. I guess we use this. Okay, so the left is 0, right is, how many is this? 3, 6, 7, 6. Okay, output is 4. Alright, so we check again whether this number is smaller than right number. It is not, so we calculate the mid. So mid is 0 plus 6 plus 0 divided by 2. So in total this all will be 3, right, which is around here, which is this one. Okay, Then we calculate our output. Our output is a minimum of the first number and middle, which in this case the first number state because it is the minimum. And then we compare the middle point again, right? This is to check whether we're at the left side, whether the middle point is at the left side array or the right side array. In this case, it is on the left side array, so we have to move our left pointer up, right? So if we move it up, then it will be this. Our left will be 3 plus 1, 4, right? 1, 2, 3, 4. And in this case, we're at the right side sorted array, and then this will trigger and return 0, right? All right, that's all I have to show. Thanks.